Welcome everyone, and a very good evening. So today we are here for a introductory session on machine learning and Vertex AI. Next slide. So it's about me. I'm Ashish Chanchal, GDSC lead at DVSIT and Google Cloud Storage and Facilitator. If you like to connect with me, you can scan this QR code and search on LinkedIn Ashish Chanchal. We will wait for 5 seconds. On the count of five, we can change the slide. One, two, three, 4, and 5. Next slide. So here is the agenda for today's session. Next slide. In this session, we will discuss introduction to machine learning, our discussion on ML, and overview of Vertex AI. And at last, we have a Q&A session. In that, you will ask your doubt. Next slide. So there is an introduction to today's speaker. Next slide. Today we have Anup sir. He is full stack architect, AWS community builder, and a YouTuber. His YouTube channel name is Learn for Therapy. Uh, on his channel have some great content on Git, GitHub, and cloud. I also learned Git from their channel. If you want to connect with him, you can scan this QR code. You can change the slide at the count of five. One, two, three, 4, and 5. Now I can hand over the stage to Anup sir. So Anup sir, it's your time.
Sure. Am I audible first of all, guys?
Yes, sir.
Okay.
Yeah, audible. Yes, yes.
Everyone, please mute yourself.
Yeah, please, guys, please mute. Okay. Yeah. Thanks, Ashish, for the great introduction, and welcome everyone to actually able to get some time out to learn something new. Or already, if you know something, you can obviously improve, or basically you can reevaluate your existing learning. Okay. So I want to keep this thing very simple to make sure that you understand, considering the visitors, the audience are very new to AI/ML, or there are a lot of buzzwords going in the market related to Gen AI and everything is Chat GPT, OpenAI, right? Let's break it down. Let's break it down in a simpler manner, and then we will talk about Vertex AI and the fundamentals of Vertex AI, how the Google is able to give a solution on the Google Cloud, which we can use in order to build any AI solution. Okay. I hope everybody is okay with my English, or I can also convert it into Hindi whenever applicable. Okay. So I want to keep it very simple. Okay, हम हिंदी में भी बात कर सकते हैं, इंग्लिश में भी. Okay. So is anyone in this group is do not understand Hindi? So I will completely talk in English. Okay. Okay. Ritesh, can you be on mute? Yes, thanks. So I will be sharing my screen quickly and talking about the ML part quickly on the open board, and then we'll be talking on the Google Cloud Vertex AI part. Okay. So let me know if my screen is visible to you guys. Okay. Okay, thanks. So I will be talking on this whiteboard quickly in a very simple manner. Okay. So when we say AI, right? When we say AI, we normally call it along with ML, right? So what exactly is AI when we say AI? So what we are doing, like in the normal terminology, we as a human do some task, and this consider as a, like all of the human beings are doing tasks, but we want to involve computer and help. So what happened initially, like the user normally gives input to the system, right? Like we have a function and we pass in some parameter, and suppose it is a sum function, it gives me the output, right? So user gives the input and computer has some given instruction, set of instruction gets executed, कुछ instruction execute होती है, and then finally we get the result outcome. Okay, so there is a defined algorithm by which the computer operate and then gives the output. This is what the traditional, and also this is also the ongoing way as of now as well. Now, where does, so what user wants? User wants that this computer, yes, okay. So this computer start getting along with me, right? Instead of just listening to my instruction like a very, you say, one-sided, it also intelligently guess what could be the outcome if the input is not very clear. Okay. If I want something, some prediction, right? Suppose in the last 2 years there has been a lot of rainfall in a particular region, so I want to know that in the upcoming 5 years, what could be the weather forecast, right? So those kind of things we want to know from the computer. So those things is actually we want to involve computer. So when we want to involve computer, if computer needs to operate like has to operate completely like a human being, then it becomes an artificial intelligence, right? So the task is automated by the computer automatically, like everything is done by computer, like a human is, then it is part AI. Okay. Yes, anybody raising the hand?
No, sir, you can continue.
Okay. So this is AI. So human equivalent task is provided by computer. Now, what is ML in it? Right. So I consider it as AI. So what is ML in it? So ML is like a you can say like the way we actually teaches the kid, right? So we want to teach machine so that the machine can help us like so basically in this case I am not teaching anything to computer. I am giving input and I am assuming that it gives me output like a calculator. We give input and put a plus minus button, and then I am able to get the outcome basis on what is I am clicking on, correct? Now in case of machine learning, what we are saying, we want to train computer, we want to teach computer with a certain data set, okay, and with a prediction with the outcome, so that later on the computer can give me the outcome. Like the way I say, last 2 year the rainfall is very heavy. Okay. Now what would be the next 5 year prediction, right? So in this case, you cannot predict because I have only one entry, right? Last 2 year, I can call it as 2022 and 2023. The rainfall is heavy. Now, can you tell me like what would be the rainfall prediction for 2024 to 2029, right? So with this only two data set, can I predict? As a human being, can I predict? I cannot generally, right? Because if this is very heavy, this is very heavy, can I say the other one is heavy or low? No, no. So computer, we are saying we want to give computer enough information so that the computer can start helping us. So that is nothing but a machine learning. Okay. So teaches the machine to give us outcome. So that is machine learning. So machine learning is actually is able to solve one task, like one task. So AI, so ML is nothing but a subset of AI, and AI is nothing but a subset of computer science. Okay, basically. And then obviously you might have heard of deep learning, that is more of sits within the ML. That is deep learning, going more like neurons, how the human neurons work. So I don't want to touch that because considering it like making sure that everybody understand. Okay. So this is the high level overview of machine learning. Okay, like what sort of machine learning is. Now I want to give some I want to put it in some more context to it. Okay. Now just a few terminology. So when we call it as we generally heard the name model, right? So nowadays the fancy word is going on in the market, LLMs. Okay. And they are nothing but large language models. Okay. So that helps in giving us outcome when we provide some sort of text or images or videos, right? And then we fed, and then we get the text, images or videos, etc. Right? So these things are going. So, but the thing starts from the actual model training. So these things is like we trained with lot of data set. available in different domains, different industry, and those data set are being fed into the supercomputers, and they are training and converting it into a model. Okay, so this is what is happening nowadays. But this story begins from this particular model concept. Okay, now what is model, and what exactly is what we have to learn, how, yeah, machine learning is, how exactly is machine learning working. Okay, let me do that. So what we normally do, let's take an example. uh, we as a we as a we as a person, when we see, when we see a cat image, like when we see a cat image, we, as a human being, we already learned about the cat, right? But have you ever seen a kid? Have you ever seen a kid? Like if we want to train a kid, what we say? We call it, say, hey, this is cat, right? Suppose kid encounters the cat for the first time. So what we call to the kid, hey, this is a cat. So kid say, hey, okay, this is cat, right? Now suppose the cat color changes. It is white cat. This is black cat. Okay. Then kid might understood, may not understood this is a cat, right? Then again we call it the kid, hey, this is also a cat, right? We keep training the kid. Okay, because I have also seen practical example with my kid where we keep on training him that this is a cat, this is a cat, but something which is not exactly a cat comes in count in front of him, and he call it as a cat. Okay, but the problem is that is what the training is not done with the lots of data sets. Okay, we might have teaches with only two type of cats, but we encounter, suppose, which is like a cheetah. Okay, so I have shown to my kid a cheetah. Okay, and cheetah is more like at least the face looks like similar to cat. It comes from the cat family, right? So the kid has called it as a cat. Okay, not a cheetah. Okay, so that is where we are saying that that number of data set should be very high in order to get the result correct. Okay, so here if we are putting in only two data set and the outcome is like third is the, if I'm shown the cheetah, the outcome is still, the kid is still saying it as a cat, then it means that the prediction is what the prediction is wrong. Okay, wrong prediction. Why? Because we have trained the model, we have trained the kid. You can call it as a kid or a model. You can think of it like that. Okay. So the cat. So this data set is very low. Data set is not of, you can say, good quality, right? We have only a limited set. So this is what is needed. So like the way we actually teaches, you apply this principle to every other kid, whether you are training to for a particular image identification, right? This is nothing but an identification, a classification, right? Whether it is a cat, whether it is a dog, whether it is a computer, right? So this is known as classification problem, like in a, like formally known as classification problem, because we are asking somebody to classify whether it is a cat or dog or something, correct? This is 1 second. This is first level of problem statement, and this problem statement is known as classification. Okay, so model training for classification. Okay, now the second case, let us understand the second case. Okay, the second case is like you have suppose you can take any example, like any data set. Okay, any data set which could be like you can talk in terms of policy buyers. Okay, policy buyers. Okay, so normally what happen, like if we are undergrad, right? If we are undergrad and we are kind of independent and we fall in certain age group, right? Certain age group like 18 to 24. Okay, so and we, so basically what I'm talking about, like normally when I was in Max Life, right, what they are actually doing it, they are actually having a form. quotation form. Okay, suppose I want to buy a policy, term insurance policy. Okay, so what I will go to the any of the site which is offering the term insurance policy. Okay, so what they want us to fill, they want to us to fill like whether you are male, female, or other, or age group, whether you are smoking or not, and then whether in which like in which location you belong to, what is your salary, etc., etc. Right? So all those things are filled up within the form. You fill up the form, and finally they actually let you know कि you can take that policy. You can take that particular sum insurance. Basically, the amount is applicable for you. Like you can take a term insurance policy for 1 crore, for 1.5 crore, something like that, basis on the incoming parameter. Okay. So let me take that example like that only. Okay. Okay, so let us take one example over here. Okay, then we will move on to the Vertex AI as well. So we call it as age, we call it as gender, and then you can say salary bracket. Okay, and you can say sum assured. Sum assured is nothing but this much you need to pay, and finally you will get the uh, yeah. So what, let us call it like, suppose the age is 15, okay, and gender is male, and salary falls between 10K to 20K, basically. So we can provide you the sum assured of 5 lakh, okay. So similarly, you have multiple entries over here, okay, like this. Now, this, consider this in the tabular form, okay, and this is a CSV. CSV is nothing but this is an Excel sheet, okay. So Excel sheet is what where the spreadsheet is primarily very important, right? We have different data structure. So one is the image, right? I already discussed about image. Then we have video. Then we have tabular data, right? So these are kind of data. Then we have audio, right? So these are the data structure against which we normally train a model and then finally use it to predict anything. Okay, this is what the machine learning is all about. So we already have learned about the image. It can be treated for audio as well as video, and this example is for tabular data. Okay, so we have a tabular data, we have age, gender, salary, and this is, you can think of it as an outcome. Okay, like basis on these 3 parameter, the outcome is this, like basis on whether the age is 15, gender, and salary, like age, gender, and salary, the outcome is this value. Okay, so what these 3 things, the 3 columns, these 3 columns are known as features, which is known as features. So they are important terminology around the model training stuff in this industry, right? So what is a key feature, which is the, so this is the outcome. Okay, this is the outcome, this is the feature, this is the outcome. The individual row, this individual row is known as sample, okay. So there could be n number of rows, correct? 10 rows, 20 rows, 30 rows in this Excel sheet. So all of this individual row is known as sample, okay. And these particular columns on which the outcome dependent upon, okay. So these are known as features. Okay. Now, and this is the outcome. Now, what we are trying to say is that suppose I have 20 rows and I have the sum assured outcome. Okay. Now, this is actually become a data set. This become a data set. Like suppose I fed this information to a computer. Okay. मैंने computer को वो information दे दी है. I fed this information to computer. Like these are the rows and this is the outcome. So computer can mug up. Okay. Okay, if the age is this, gender is this, salary is this, the sum assured this, right? So this is how we are giving information to computer. The CSV file is giving to computer. Now, what would be our requirement? We say, hey, you have already taken this data set. Now, basis on this data set, predict what would be the outcome if the age is 25, gender is female, and the salary range is 30K to 50K. Now, what would be the sum assured? Okay. This is computer is going to, or the program is going to give me as an outcome. Okay. So this is what the benefit of training a model. Okay. So this is a tabular data, and basis on this tabular data, I am getting some information. So this kind of problem statement, which is a tabular data and giving us a prediction, right, basis on set of columns, this is known as regression problem. This is known as regression problem. Okay. So I just forgot to mention one thing. Like ML is divided into three different umbrella. One is supervised learning. Second is unsupervised learning. Okay. And third is reinforced learning. Supervised learning is you have something as an input and you are expecting an outcome. Okay. Like I have an image of cat. I'm showing images and want to know whether that image is a cat or a dog or something. So that is comes under the supervised learning. So classification comes under supervised learning. And then this data set problem statement is also comes under supervised learning, regression problem. Okay. And unsupervised learning is like we want to find out the clustering. Clustering in the sense grouping. Okay. Grouping in the sense like if suppose we don't know the suppose I am feeding the images to computer without even saying to computer that this is a cat or this is a dog. Okay. So what computer will do, computer will simply identify, okay, this particular type of this type of looking image, all of these five, suppose I've given 10 images to computer. Okay. Out of those 10 images, 5 images of cat and 5 images of dog. Okay. But while giving these 10 images to computer, the program I'm talking about, I'm not saying to program that this is a cat, this is a dog. Okay. But I want to know from computer, from the program, that group them like which are similar looking. Okay. So what the program will do, it will group all 5 cats separately and all 5 dogs separately basis on its intelligence. Okay. So this kind of grouping, if you want to get it from the program, then this is a problem of clustering. Okay. This kind of problem is known as clustering. Okay. And this comes under the unsupervised learning. Okay. And third is the reinforced learning. Reinforced learning is like giving incentive to do something for something. Okay. Like we normally give some chocolates and candies to kids to do something, right? If you do this, then I will give you a chocolate, right? So they keep on doing it without knowing whether it is correct or not or whatever. We want it to actually, we reward something to get something done. So that is known as reinforced learning. Okay. But everyone should focus only on this primarily. Okay. Only on this. That is not going to help if you spend more of your time over here. Primarily, you are in this era of AI, ML, LLM space, or in this Gen AI space. So supervised and Gen AI. So Gen AI is built on top of supervised learning only primarily. Okay. So focus on supervised and Gen AI stuff primarily. So yeah. So this is about concept about training a model. Okay. And let me just. So what we are going to do in the Vertex AI. Okay. So what happened, like I'm going to talk about that column, tabular column. So we have the age, gender, right, and what we have, salary, right? So these are nothing but features. These are nothing but features. Okay. These features are fed, they act as a inputs. These features are fed to train a model. Okay. Basically there are set of functions provided by Python libraries, and to those functions we pass in this data, this CSV data. Okay. What we have a CSV file. Okay. So the first step is load the CSV file. Load CSV file. Okay. Second step is iterate over each row individually, one by one. Loop, we will loop it over individual row and then feed it to a function. Okay. Feed each row to a function. Okay, the function is like in, if you go with the, so there are two type of library for ML training. One is the TensorFlow, second is PyTorch. Okay, TensorFlow is backed by Google. Okay, so it is also open source. So yeah, so tensor, we can use either TensorFlow, this is deep learning library basically, and we can also use PyTorch. Okay, so these two, they are providing a set of functions in order to take this data as input and then return an output. Okay, basically that output we can use to predict anything. Okay, so it, we need to feed these row values like c1, c2, c3, these three columns. Okay, individually, and once we are done with this, we will get the output, and then we can simply use this output. Suppose my output is this. Output is nothing but a model itself. Okay, output is nothing but a model. So then after getting the model, so model is nothing but, you can think of it as an object. Okay, like in C++, we have the object, right? So it is nothing but an object, simple object. So if we give some input to it, suppose I'm giving like, okay, the training is done, I am having the object ready. Now give me the prediction if the age is 25, gender is female, and salary is 30K. Okay, then this model will give the output. So this is how the entire ML work. We first train with the help of function and feed in the data, iterating each row, and finally get the object. And then we again feed in the data as a requirement, like we put in the data in the calculator, right? Then we feed in the question or input, and then we get the output, like the chat GPT, right? We put in the query to the chat GPT, we get the outcome. Similarly, we put in the input as a row or as a value, and then we get the output. So this is how the model training or ML work. Okay, now it can be like, there are lots of algorithms in each category. We have 5 to 6 algorithms in supervised learning, 5 to 6 algorithms in unsupervised learning, 2, 3, 4 or in the reinforced learning. Okay, so each of these algorithms has their own use cases. Like it could be a weather prediction, house valuation, right? There are a lot of predictive models could be, or classification problems could be. So basis on that, we have different category of models. Okay, similarly, we have a Gen AI model, whose responsibility is to give me, in case of Gen AI, we have a text to text translation. Basically, we give input in some text, image or video, and we get the output in some text, image or video. It works little differently the way we do this traditional approaches. Okay, now if you go through and research on the Google about AI, ML or machine learning, core machine learning, then you will find out lot of calculation mathematics going on. But if you go into the Gen AI space, it's more of like querying something and getting the result. We are happy. This is happy path. Okay, so if you want to really go into that space, then understand the core part, primarily regression and classification, do some problem there, and then go to the Gen AI part. You will definitely like that approach. Okay, and this is how the things are working. Now let's go to the Vertex AI, and we will going to train a particular image. So there is one concept of labeling. Okay, let me talk about it. Okay, so that concept comes under classification problem. Okay, so what we normally do, we suppose have a image of cat. Okay, so labeling is nothing but saying that this is an image of a cat. So we actually give image, some image. Suppose we download an image of a cat from internet. Okay, and then we call, explicitly call that it is a cat. So this is nothing but label. We are labeling it separately. Okay, suppose I have an image of dog. I'm explicitly saying to computer that it is a image of dog. Okay, suppose image of some biscuit or some chips. So we call separately to computer, hey, it is an image of biscuit, this is an image of xyz. So this is not known as labeling or annotation. That's a very important term. Okay. So we label explicitly that I am feeding you 10 images of cat. I am labeling it cat, 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 dog, 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 like that. I am giving it to the computer. Now, if I am giving some 11th image for testing purpose, like some random cat image, and then the computer needs to tell me, like the program needs to tell me whether it is a cat or a dog. Okay. Because I have already given 10 images of cat to him, to the computer, 10 images of dog to the computer. Now I am asking to the computer whether this particular image, any new image, whether it is a cat or a dog. Okay. So this is a classification problem, and this is what we are going to do in the Vertex AI, and we'll explore what Vertex AI is giving to us. Okay. As of now, any query, if you want to ask, if anybody wants to say anything, just you can raise hand.
So there are some queries in chat. Chat.
Okay, give me a second. Okay. Okay. Whiteboard. Yeah, we are using the open board basically. This is open source tool. Okay. Prediction of cheetah as a cat is classification problem, but maybe it is classified the objects class. I did not get exactly what we are trying to ask here, Parunjal. So basically, I was talking about we are classifying this whether the image is a cheetah or a cat. What you are asking, I'm not sure. So raw data, like raw data. Okay, you are relating that question. I'm not able to get that, Pranjal. Can you rephrase your words and we'll get back to your question? Okay.
Anjali, if you are here, you can unmute yourself and ask me out.
Maybe not over the call or something. Okay, no problem. Let me just continue on the Vertex AI part. Okay. Okay, my screen is visible to everyone, guys.
Yes, sir.
Okay. So this is the, let me just close this up a bit. Okay. So this is the dashboard for Vertex AI. Those who do not have an account in Google, they can simply, obviously it's not very simple process. It has credit debit card and it takes time to sign up onto the Google account. But those who already have it is fine. So we just have to go to the Vertex AI. Like simply search on the or search on this Vertex AI. And once you landed on the dashboard of Vertex AI, it will ask you to enable all the Vertex API, right? If and then over here there will be over here there will be a button, enable Vertex APIs. So you need to click on that button and you're good to go. Okay. So what is Vertex AI and what they are offering? Okay. So normally when we do something like this, training a model, so what we are normally do, we download few images from the internet or video or a CSV file, data from Kaggle or some data repository, right? We download that data set and then we open up the VS Code or Spider and write up the Python code, and then we make use of that data set to train the model, and we will be able to see the outcome. Okay. So this is the normal approach. Do you think that by doing this I am done? Whether my solution is can I distribute this solution to anybody who can use it? No, right? It can only be a program that runs on my system, maybe to my friend's system if I pass on that information, correct? But do you really think whether it is usable? Can I make it usable to the world like Chat GPT, right? So Chat GPT is usable by us simply without even running that particular code into our system, correct? Similarly, Vertex AI is a solution by the Google to create program either from the Vertex AI itself or you can have the program created at your system, but bundle that particular program and run it within the Vertex AI, right, to train the model, and then finally deploy that model like we normally deploy a service. We write a REST API or a front end application or a back end application. We deploy it into the Google Cloud, correct, or a AWS or something. But similarly, here also we have piece of code. Like suppose I have 5 lines of code that I am using it to train a model. Now, Vertex AI says that if you have 5 lines of code and a data set with you, give that into the Vertex AI console. Like there are options over here. What we are going to do, instead of your computer training, suppose I have very complex case. I want to train. I have a CSV file or Excel sheet with 1 million record. Okay, I want to train it. Now to train a 1 million record into my computer, it will take lot of time, and that too basis on you have the supported hardware. Like CPU is very high, memory it requires 16 GB or 32 GB, 64 GB sometimes, or GTX 3060, which is very costly, right? So all of these are the hardware requirements in order to train a complex data set, in order to train on top of the complex data set, correct? So Vertex AI is a solution where they are saying that bring your data to us, write some code, pass on to us, or even use the Google Colab or write directly into that. We and configure it whether you want to train it on CPU, GPU, TPU, etc. Put the RAM configuration, etc. in the console itself, and then we will train that model for you, and it will keep on running until the training complete. You can go and sleep and have a cup of tea, etc. You can continue the work on your computer. We will train model for you, and once done, we will notify you, and then you can make use of that particular model. We will provide you the REST API, and then use that REST API in your code piece. That's it, or done. This is what the Vertex AI is. Okay, I hope you are able to get the grasp of it. Now, what the Vertex AI normally gives, if you look into this entire panel, it gives us a coding like VS Code kind of an experience. So Colab Enterprise, a collaboration tool where we can simply write the code within that particular within this browser itself. It gives us pre-trained model. Like suppose you want to train a model like on gender. You want to identify a gender. So there are a lot of pre-trained model given by Google. You can simply use it instead of training yourself. So third is you have Vertex AI Studio, which is basically for Gen AI related stuff. You can make use of it. There is a prepare data. Suppose you do not have you do not have data set ready. You can prepare data directly over here. Okay. You can directly label your images by using this prepare data panel. Okay. And then you can train your model like the way I told you earlier, right? You can train it over here itself and finally deploy it so that you can use it. So let me talk about it quickly. So if I show you the model garden, so you might have heard of that latest releases in this space, Gemini Pro Vision, right? This is LLMs, all of these LLMs, Mistral 8.7b, this is awesome model, like almost sorts. So these are the LLM models they are already giving to us as a pre-trained model. We can simply go and use it. Okay. So they are already deployed. We can simply use the REST API and we can directly use it. So mostly maximum use cases are covered by these models. You just have to search. Suppose if you want to build some application which is basis on the tabular data, or this is a object detection related stuff, you can simply search for it and find that model and use it. Okay, that's on a high level explanation of the model garden. Then I want to touch upon quickly the data set part. Suppose you have some images. I do have certain images of Oreo biscuit. So what we can do, like we can go to the create data set. Now it gives us I already told you data structure, right? Image, tabular, text, and video. These are the data structure on which we normally train anything. Like machine learning works on this kind of data structure. Okay. So it says that if you have an image, if you want to classify a particular image, you can use this. If you want to classify if there in a single image, if there are two objects, more than one objects, then you can use this option. If you want to detect an object like a boundary, here there is no bounding box, correct? These are just a label. But if you want to have a bounding box in the image, right? So then you can make use of this image object detection, and this is pixel level information. So this is segmentation. So segmentation is like go by pixel, use a colored solid color, right? So these four kind of model training is possible. So if I select this and use create, click on this create button. Okay. Okay. So it says that upload images from your computer. Okay. Or upload import files from your computer. Select import files from cloud storage. Suppose I want to upload directly from my computer. So I can select files, right? I can select files from here. Sorry. Uh, Documents. Sorry. Where should I see this? Okay. Audio images I have, right? So I can select directly from here. Suppose I pick this image and choose it. Okay. So I can also select more than one file, right? So if I want to get accurate result, like at least bare minimum accurate result, so the recommendation by Google is at least 10 images we have to provide. Okay. So just for the sake of this discussion, I can show you one image how it looks. So we have uploaded one image. We can continue. Okay. It says that okay, I have specified a bucket over here by default, but that specified a bucket over here. So I can change that bucket. So what we have to do, like we have to create a bucket basically. You have to go to the cloud storage. What happens basically, those whatever images we are passing into this, it basically upload that image to this bucket. So the bucket should be existing. So we just have to create a bucket. Click any name, like which is a, you can call it as vertex images. Okay, as a bucket name, you can name it as per your requirement. Okay, and just bucket name is the people are already using it. That's for sure. So it should be unique. That is also, oh my god. So call it like this. Any random number. Okay. So continue like okay. Just for the sake, it's not mandatory. Just I we don't want any high availability kind of thing, so we can choose low. So we just continue and yeah, create that bucket. Okay. Okay. Let us choose anything as of now, just for the sake of brevity. So we have actually created a bucket. Just copy this bucket name and just go back to the Vertex AI. Okay. Choose Vertex AI and come back over here. Maybe we are already creating this recent data sets. Okay. So I've selected the recent data set that I've created and then select upload images from your computer and then select files and then this, choose the audio images, anyone, and then in here you can browse uh, buckets, which is this one, right? And select. So I've checked. Now I've selected the bucket name. We can click on the continue button. All right. So image is uploaded. Now I call this is no label. Why? Because I have given the computer in image, but I'm not saying it is an Oreo, correct? Because computer is not smartly taking that name out of the image. It's up to us to give that label, that information back to the computer, right? To the system, or whatever you call it. So if you want to label it, so we can select this. Okay, assign labels. I told you earlier, like, so we can say assign label. So I've just double click on it. It opens up, and now it says that add label option. Okay, click on add label. Now it is an Oreo, right? So we can call it as Oreo. Oreo can be any other name as well. So whatever you can call it as of now, that Oreo. We can label it as Oreo biscuit. Okay, like this. Okay, so this is a label I'm giving. So this dash is not basically. So you can call it as Oreo itself. Okay. So now it is labeled. Like, click on save button. Okay. This is saved. Okay. Now it is labeled. If I go back, now it is labeled. Okay. Now we can simply go to see the, and we can analyze this. Now you see that what it says. It says that you have only given me only one image. I told earlier, right? It requires 10 images assigned to each, like two labels. Okay. So if this one is, they want to actually predict correctly, right? So they are saying that at least give me the 10 images, then I can work on it. Okay. But yes, considering the time shortage, but I could have trained it for all the Oreo images I have, which is 10 images, right? So all of these images can be fed like this only, and label can be provided. Once that label is provided, what is the next step? I can talk about it. The next step is, once this is done, the next step is actually deploy. Then the next step is training. Okay. The next step is training. Once we are done with this data set, then the next step is training. Okay. Now over here in this training, what we do, we actually train new model. Okay. And then in this train new model, we have to select the data set. This is the data set we have already created, right? With one image. But in practical, when you go back to the Vertex AI, train it with 10, prepare the data set with 10 images, first thing, and then you will automatically, this information, keep it as it is. Auto ML is, this is given by Vertex AI itself. Okay. So like kind of a compute, basically it used its own algorithm to train a model. If you want to give your own program, like TensorFlow program or a Python program or scikit-learn program, you can simply choose this option, and then you can put pass in the relevant code to Google. Okay. Or you can choose this option, continue, and then train new model or new version. You can give any name here, continue. Okay. And what should be the accuracy? Higher accuracy or lower accuracy? Like actually giving me the right outcome, like, or a default. And then finally you have to set in the budget, basically how many hours it will keep on training, right? So the minimum, if you see, you can train for as little as 8 node hours. So basically it runs for 8 hours and train that particular model. Like if I choose in that, then it simply clicks start training, and it will take 8 hours to train a particular model, right? So but this is the 8 hours maximum node hours. Okay. On a highest, but obviously this model is very smallest of a model, so it says that estimated completion is 1 hour. Okay. So you can get this model training completed within 1 hour. After this model training, once you are done with this step, the third step is to, this is second step. The third step is to, you can deploy a model. Okay. So once you are done with this training, this is third is the model training. Okay. So what normally happen when the model training is completed, the model is visible over here, okay, in the model registry. Okay. And then you can click on the, this is the model registry. So this either basically this step creating from here and or training from here is the same step. Okay. If you are training from here or if you are creating from here, it's the same step. Ultimately, it will fall under this registry only. Okay, like this. And once the registry is there, so it gives us an option to use the REST API. Basically, if you click on this, you can use it. You might have heard of like you normally what you do to actually access a chat GPT or OpenAI. What do? You have the access key, right? You have the URL. You make use of the URL. You make use of the key, and you are able to make a call to the OpenAI. Correct. Similarly, once you are done with the training of the model, you will be able to call that model with the API. So once the model registry have this model over here, you should be able to call that API in order to access it. Okay. So on a high level, this is what the Vertex AI is, and there are a lot of features over here. So in the data set, there is one thing. Like once the training of this model is done, there are very important steps. This one, hyperparameter tuning job. So what does this mean is, like once suppose basis on the data, one CSV file or something, the model is trained. Okay, but it happens that in the columns on the CSV file, it may happen that but one of a column in that CSV file is not adding more value, like not adding more value in the outcome. Suppose my sum assured is not dependent upon whether not dependent upon the gender. Okay, then in that case we can reduce the data set and remove that gender column altogether. Okay, so what we are feeding, so we can tune that particular entire experience, right, so that the outcome will be more performant, we have more accuracy. Okay, so those kind of things is uh, tuning. So we can have this kind of things happening within the Google Cloud, and we can tune further in order to get the more predicted outcome, right? So these are the things that we normally do in the Vertex AI. Okay. So yeah, so we can close this up. Like this one means pipelines. So pipeline approach is actually, if you read through it, is ML ops. What it says that you train a model, you deploy a model, you use a model. This is what you are doing, correct? But you can add it like a workflow in the sense, like if I go to this board quickly to wrap it up. So workflow is like what you normally do. We have data sources. Some data source can be CSV file, can be a data from sensor data, right? Can be data from sensor data or navigation data, like flight navigation data or vehicle navigation data, GPS data, correct? So all these are basically act as a data source. So this data source will first needs to ingest. So first needs to ingest. Then we have to clean that data, right? So that is known as transform that data. So it may happen that in a single Excel sheet, out of 20 record, one of that record is correct or incorrect. Basically, we want to get rid of that row. We want to fix the date and time of that particular column. So that is nothing but transformation to make it useful. And then we feed the data to model to train the model. Okay. So before that also we can have a step like the way say annotate, right? The labeling. This is what we did manually, correct? And then we have training the data and to convert it into a model. And then we have evaluation. Obviously, immediately after training the model, you cannot use it directly in the production, right? You have to do testing, like the way you test a code. So that is nothing but evaluation. You want to test it, correct? And then you want to deploy it. And this is the pipeline, nothing but a pipeline. So with the help of pipeline, you can basically create the workflow, and you can write some code here, 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 and then smoothly the entire pipeline will be able to convert this into a model, and then model can be used into the production. So there I would like to wrap it up the session on the ML and Vertex AI. Hope you understand this. This is beginning. This is a beginner live, but yes, on a high level, it covers the basics, fundamentals of ML, and how we can make use of Vertex AI in order to train a model and deploy a model into the Vertex AI. And there are model garden. If you are not sure about how to train a model, or you don't want to spend money in order to train a model, you can simply take a model out of the model garden like Gemini Pro, etc., and use it in the form of API. Okay. Yeah. Yes, Paul.
Sir, the Coco SSD model was also trained by like this way.
Yeah, yeah. You are talking about the Cocoa model, right?
Yeah.
Yes, yes. Normally, whatever models you are talking about the pipeline kind of, or what you are asking? This pipeline, the way we are doing.
No, no sir. The Coco, you know about Coco SSD model?
Yes, yes, yes.
Yes.
What's your question?
I want to say that Coco SSD model was also made by this way or from any other else way.
So no, this the fundamental concept remains the same. So these models are like this way only. The difference is that whatever the algorithms behind the scene that runs in order to train a model. So the high level fundamental is this only. So the algorithms, the usage, the purpose will differ, and basis on that they are applied within the system, whether it is applied via Google Cloud or locally or any AWS or something.
I want to say that here we didn't use any coding type things and algorithm also. Means Google developed Vertex AI just for to leave the algorithm etc. type thing.
No, no. Here, if you have the custom model approach, like, so we have two things here: auto ML and custom. Okay. So if you choose in the custom, you need to write a code into the Google Colab here, Colab Enterprise. Okay. You need
Okay, okay, that's I want to say.
okay. You need to write
Thank you,
code
sir.
here, integrate it. Okay.
Okay, thank you, sir.
Okay. Any other query, guys? Okay. Sure. I think we can wrap, Ashish. We can. Okay.
Thank you so much, sir. It's such a great session. As I am not from ML guy, but you really explained everything really well. I hope everyone will get something for the session. So if everyone have a proper time, so everyone can open this camera. We can click a group photo.
Yeah, if it's
We can
possible, let's have
share
a.
on LinkedIn and tag.
I can stop sharing if it is shared, right? I can stop sharing.
Yeah, okay. Yeah, shoot. Please click a group photo.
Yeah, done, guys.
Okay, sure. Thanks for joining, guys, and yeah, keep attending those kind of sessions. Very simple. And very, okay, guys. Bye.
Bye everyone.
Bye.